Normandy, 1944. A German Panzer commander peers through his periscope as Shermans move like a single deadly machine. His radio hisses with static, orders lost, chaos rising. Across the field, American tanks call in airstrikes, shift formations, and coordinate fire, all through crystal-clear radios. The secret weapon wasn't the gun or the armor. It was something far more powerful: communication. When you think about what won battles in World War II, your mind probably jumps to firepower, armor thickness, or speed. But here's what most people miss. The Sherman tank packed a communication system that was nearly a decade ahead of its time. Inside every Sherman sat the SCR-508 radio system. To understand why this mattered, imagine trying to fight a battle where you can't talk to the guy standing right next to you. That was the reality for most armies at the start of the war. The Sherman changed everything. This wasn't just some bulky radio set thrown into a tank as an afterthought. Bell Labs designed the SCR-508 from the ground up for one purpose: to let tanks fight as a coordinated team instead of individual metal boxes wandering around the battlefield hoping for the best. The system weighed 181 pounds and included a BC-604 transmitter and two BC-603 receivers, all mounted on a specially designed tray in the turret bustle. But here's where it gets interesting. That weight came with capabilities that would make modern military planners nod in approval. Sherman crews could transmit on 10 different FM channels and listen on up to 20 channels if they carried all the frequency crystals. Think about that for a second. While German tanks were often stuck on one or two frequencies, American tankers could hop between channels like a modern cell phone switching towers. Did you know? The Sherman's radio could maintain clear communication up to 7 miles while moving in 10 to 15 miles when stationary. German Panzer radios, by contrast, could barely manage 2 to 3 kilometers with voice communication before their AM signals degraded into useless noise. But the real genius wasn't just about distance. The Sherman used frequency modulation, FM radio. Everyone listening to this has probably heard FM on their car radio, but in 1941, when the SCR-508 was standardized, FM was cutting-edge technology. Most civilian radio stations hadn't even adopted it yet. So why did FM matter so much? Let me paint you a picture of what it was like inside a World War II tank. You've got a massive engine rumbling behind you, tracks clanking against the ground, the turret motor whining as it rotates, shells being loaded, the main gun firing, all creating an electrical storm of interference. Every spark plug firing, every motor running, every electrical component generates radio noise that can turn AM radio signals into complete garbage. German Panzer tanks used AM, amplitude modulation. Their FUG-5 radio system, standard in most Panzers, operated with 10 watts of power on AM frequencies. When that Panzer's engine was running at full throttle, when electrical systems were drawing maximum power, those AM signals would get buried in static. The Sherman's FM system cut right through that noise like it wasn't even there. Frequency modulation doesn't care about interference from electrical systems the way AM does. A Sherman tank commander could be racing across a battlefield, engine screaming, electrical systems maxed out, and his radio would still deliver crystal-clear communication to every tank in his platoon. But it gets better. The SCR-508 had 2 receivers. Why 2? Because command isn't just about talking, it's about listening to multiple conversations at once. A Sherman tank commander could monitor his platoon on one receiver while simultaneously listening to battalion headquarters on the other. He could hear orders coming down from above while coordinating with tanks on his left and right. German commanders? They had to choose. Listen to your tanks or listen to headquarters. You couldn't do both effectively. Did you know? The SCR-508 system included a squelch circuit, a feature that automatically cut out static when no one was transmitting. German radios didn't have this. Their crews had to listen to constant background noise, making it harder to catch important transmissions and causing ear fatigue during long engagements. The entire Sherman intercom system ran through this radio setup. The driver, co-driver, gunner, loader, and commander could all talk to each other through BC-606 interphone control boxes mounted at each crew station. Only the commander could transmit on the external radio, but everyone could listen. Everyone stayed in the loop. Compare that to German tanks in the early war years. Until 1941, when they introduced the Panzerkasten 20 amplifier box, German tank crews couldn't even get their gunner on the intercom network. The loader never got connected at all because he had to move around too much to handle ammunition. Here's something that sounds technical, but was absolutely game-changing. Crystal-controlled frequency selection. The Sherman's BC-604 transmitter used quartz crystals to set precise frequencies. These crystals were like physical keys that unlocked specific radio channels. Swap out a crystal, and you instantly had a new secure frequency to operate on. The transmitter had a drawer specifically designed to hold all 80 possible channel crystals for its 20 to 27.9 megahertz range. Why did this matter on the battlefield? Imagine you're coordinating an attack. Your battalion is using channel 7. Suddenly, you realize the Germans might be listening in, or worse, jamming your frequency. In a Sherman, switching channels took seconds. Pull out one crystal, pop in another, and boom, you're on a completely different frequency that the enemy hasn't found yet. German Fu-G5 radios offered 125 channels with 50 kilohertz spacing. That sounds impressive until you realize those channels required physically adjusting tuning mechanisms and carefully setting dials. In the chaos of combat, precision dial tuning was a luxury most crews couldn't afford. Plus, their AM signals were easier to intercept and jam. The Sherman's crystal system meant preset, reliable, instantly accessible channels. No fiddling with dials while someone's shooting at you. No worrying if you're exactly on frequency. Pop in the crystal, press the button, and you're talking. Command tanks, the ones battalion commanders rode in, got an additional radio, the SCR-506. This monster weighed 176 pounds and could communicate with regimental and division headquarters on completely different frequency ranges. A battalion commander in his Sherman could listen to division orders on the SCR-506 while simultaneously coordinating his tank companies on the standard SCR-508. Two completely independent radio nets, both operating perfectly in the same tank. Did you know? The Sherman's BC-603 receiver had mechanical push-button presets, similar to old car radios. Crews could preset their most used frequencies and switch between them with a simple button press. This technology seems basic now, but in 1941 it was like having speed dial in a world where everyone else was still using rotary phones. This flexibility extended down to the smallest tactical level. A platoon of 5 Shermans could spread out across a battlefield, each tank maintaining constant communication with the others. When they needed to coordinate with infantry or artillery, they could switch channels without losing their internal platoon net. When air support came in, they could hop to another channel to talk to the fighter bombers overhead. German tanks? They fought with far less flexibility. The standard Fu-G5 in most panzers gave them solid communication within their immediate unit, but coordinating across different branches, tanks, infantry, artillery, air support, required messenger runs or hope that somebody at headquarters was successfully relaying information through their limited command radio systems. Let's talk about something that determined who won and who died. Radio range. The Sherman's SCR-508 transmitted at 25 watts of power. The German Fu-G5 transmitted at 10 watts. That power difference might not sound like much, but in the world of radio physics, it translated to massive practical advantages. With 25 watts and FM's resistance to interference, a Sherman could maintain reliable voice communication up to 7 miles while moving and 10 to 15 miles when stationary. A German Panzer with its 10-watt AM system, about 2 to 3 kilometers for voice, barely over a mile. In Morse code, they could push to maybe 4 kilometers. But combat doesn't give you time to tap out messages in dots and dashes when you're taking fire. Picture this tactical scenario. an American armored division advancing across France. Sherman platoons are spread across a front 5 miles wide. Every tank can still talk to battalion headquarters. The battalion commander can coordinate all his companies simultaneously. Air support calls can reach fighter bombers overhead. Artillery requests get through clearly. Now, picture the German side. Panzer companies have to stay bunched together because if they spread out more than a mile or two, they lose radio contact. Orders from regimental headquarters have to be relayed through multiple tanks because the direct range isn't there. The coordination that American forces took for granted, German commanders had to achieve it through pre-planning, rigid formations, and hoping nothing unexpected happened. This range advantage fundamentally changed how Americans could employ their armor. They could execute fluid, mobile warfare because their tanks could talk to each other across distances that would leave German formations isolated and confused. And here's a detail that makes all the difference. The Sherman's radio worked on 12 or 24-volt power systems. The dynamotors that stepped up voltage for the radio tubes were designed to handle either power supply. This made the radios adaptable across different tank models and even other vehicles. German radio systems were often more finicky about their power requirements, leading to compatibility headaches. Did you know? The SCR-508's receivers and transmitters used rugged metal-jacketed octal-base vacuum tubes instead of standard glass tubes. These could handle the brutal vibration, heat, and shock inside a tank far better than civilian radio components. German radios also used sturdy tubes, but the American approach to ruggedization was arguably more systematic. Bell Labs had designed these sets specifically for armored vehicle use, not adapted existing technology. The Sherman's greater radio range meant American commanders could see more of the battlefield through their communication network. A battalion commander sitting in his command tank could maintain direct contact with all his company commanders. He could hear battlefield conditions in real time. He could adjust plans on the fly based on what his subordinates were reporting. German commanders? They often had to rely on messengers, signal flags, or carefully planned operations where everyone knew their role beforehand because maintaining communication was difficult. Now, let's talk about something that seems obvious today but was revolutionary then: the integrated intercom system. Every Sherman crew station had a BC-606 interphone control box. The driver in his seat up front, the co-driver beside him, the gunner and loader in the turret, and the commander standing in his hatch. All of them could communicate with each other instantly. The system was so well integrated that it ran through the same radio set that handled external communications. This might not sound impressive until you understand what tank combat was actually like. A tank buttoned up, all hatches closed, is effectively deaf and blind to the outside world. The engine noise alone is deafening. The crash of the main gun firing can rupture eardrums. The metallic clang of tracks, the squeal of the turret traverse, the clatter of spent shell casings. It's a symphony of industrial violence. Without an intercom, crew members had to shout, use hand signals, or physically grab each other to communicate. In combat, when every second counts, this was a fatal disadvantage. The Sherman's intercom meant the commander could give orders to the driver while simultaneously directing the gunner. Driver, back up 20 yards. Gunner, traverse left. I see a target at 2 o'clock. The entire crew operated as a synchronized unit because they could all hear each other clearly despite the chaos around them. German tanks improved their intercom systems throughout the war. Early Panzers had severely limited crew communication. As mentioned earlier, until the Panzerkasten 20 amplifier was introduced in 1941, German gunners couldn't even be included in the intercom network. The Panther-Fibel, the German tank manual, actually celebrated when gunners finally got connected to the intercom, calling it the ultimate dream comes true. But even then, German tank loaders remained off the network because they needed to move around the tank to grab ammunition. The Sherman's integrated system was designed from the start to include all crew members in the communication loop. This integration extended to a clever feature many people don't know about: the tank infantry phone. As the war progressed and Americans realized their FM tank radios couldn't talk to the AM radios infantry carried, they added an external phone box on the back of many Shermans. Infantry soldiers could pick up this phone and talk directly to the tank commander through the intercom system. This solved one of the biggest problems in combined arms warfare: tanks and infantry being unable to communicate when the tank buttoned up under fire. Did you know? The Sherman's intercom system had individual volume controls at each crew station. This meant the driver, who sat right next to the loud engine, could turn up his headset volume while the commander could keep his lower. Small detail, huge impact on crew effectiveness during long operations. Here's where we get to the heart of why Sherman radio superiority mattered so much: command and control. Modern military forces understand that information dominance wins wars. The side that can see the battlefield more clearly, communicate orders faster, and coordinate actions across multiple units has a decisive advantage. In World War II, the Sherman's radio system gave American armored forces exactly that advantage. Consider how an American armored battalion operated. The battalion commander's Sherman had both an SCR-508 for tactical communication with his companies and an SCR-506 for strategic communication with regimental and divisional headquarters. He could receive orders from above, assess his tactical situation, and issue commands to all his subordinate units, all in real time. Company commanders could talk to their platoon leaders could talk to individual tank commanders. The entire organization functioned as a connected network where information flowed up and orders flowed down with minimal delay. German armored units, despite their tactical brilliance and aggressive doctrine, often struggled with this level of coordination. Their early victories in Poland and France came from excellent pre-planning, rigid adherence to operational schedules, and commanders who understood their mission so well they could operate independently when communications failed, because communications frequently did fail. The German military doctrine emphasized mission-type tactics: give subordinates a goal and let them figure out how to achieve it. This worked brilliantly when things went according to plan. But when the unexpected happened, when flexibility was needed, when rapid coordination across multiple units could seize an opportunity or avert disaster, the Americans often had the edge because they could actually talk to each other. Did you know? American tank crews were trained to use proper radio procedure with call signs, message formats, and discipline. Red 2 to Red 1. Enemy armor 2 o'clock, range 800 over. This standardized communication meant orders got through clearly even in the chaos of battle. Historical transcripts from battles like Okinawa show Sherman crews maintaining remarkably professional radio discipline even under intense fire. The Sherman's dual receiver setup was particularly clever for command and control. A platoon leader could keep one receiver locked on his company commander's frequency while using the other to monitor his platoon's tactical net. He never missed orders from above, but he also stayed connected to his tanks in real time. This constant connectivity meant American forces could execute complex maneuvers that would be nearly impossible with poor communications. Converging attacks from multiple directions, coordinated infantry armor assaults, artillery support adjusted on the fly, airstrikes called in by forward observers in tanks. All of this required the kind of reliable, clear, long-range communication the Sherman's radio system provided. German forces could and did execute all these types of operations too, but they often relied more on careful pre-planning and rigid schedules because they couldn't adjust on the fly as easily. When American armored forces encountered unexpected situations, their superior communication meant they could adapt faster. Now let's zoom out and look at the strategic implications. The Sherman's advanced radio system wasn't just about tank-to-tank communication. It was a fundamental enabler of American combined arms doctrine, the idea that infantry, armor, artillery, and air power should fight as a coordinated team rather than as separate forces. American doctrine, built on British experience from World War I and their own innovations, recognized early that modern warfare required different branches to support each other. Tanks needed infantry to clear buildings and protect them from enemy anti-tank crews. Infantry needed tanks to break through fortifications. Both needed artillery to suppress enemy positions, and everyone benefited from air support. Making this coordination work required communication. The Sherman's radio was the technological foundation that made American combined arms tactics possible. Throughout the war, Americans continually improved their radio integration. When they discovered that Sherman FM radios couldn't talk to infantry AM radios, they added the AN/VRC-3 system, essentially taking the same BC-1000 backpack radio infantry squads carried and installing it in tanks. Sherman commanders could switch between their tactical tank net and the infantry net with the flip of a switch. This kind of improvisation and integration was harder for German forces. Their tank radios operated on different frequencies than their infantry radios. Their artillery forward observers often couldn't talk directly to tanks. Coordinating combined arms attacks required messenger runs, prearranged signals, or commanders exposing themselves by riding with their heads out of the hatch to shout at infantry. The Americans solved these problems systematically because their radio technology gave them the flexibility to do so. You can't integrate what won't communicate. The Sherman's radio system was part of a larger American advantage in electronics and communication technology. While German engineers made remarkable advances in optics, armor metallurgy, and weapons design, American industry dominated in radio technology, radar, and electronic systems. This wasn't an accident. American civilian industry had developed extensive commercial radio infrastructure before the war. Bell Labs, RCA, and other companies had been perfecting radio technology for commercial broadcasting and telephone systems. When war came, that expertise transferred directly to military applications. The Germans were playing catch-up in an area where the Americans had a generational lead. Even late-war German radio improvements couldn't fully close the gap because the Americans kept innovating too. If this story opened your eyes to the hidden ways technology shaped victory, go watch the next video on our channel. It's another forgotten piece of history that'll change the way you see the past.